Describe the shape of the curve y equals x cubed minus 3x squared at the point where x is first 2 and then x is negative 2. So I have to start off by saying y equals x cubed minus 3x squared. We're busy with number A. My first derivative equals 3x squared minus 6x. My second derivative equals 3, that's not true. 3 times 2 is 6x minus 6. Now what I want to do is I want to find out what is the second derivative at x equals 2. That gives us 6 times 2 minus 6. 12 minus 6 is negative 6. Because this is negative 6, it is a negative value. Sorry, it's not negative 6, it's positive 6. Because this is positive, all right, positive 6. 6 is positive. Therefore, I have, like in parabolas, that's how I remember it. If that is positive, I'm smiling. It doesn't mean that this is a minimum point. It just means that it is concaved up. So therefore, concaved up. The graph is concaved up at that point. The curve is concaved up at x. Let's just move that at x equals 2. Let's now look at number 2. The second derivative at negative 2 will give us 6 times negative 2 minus 6. That will give us negative 12. Take away 18 is negative 18. If it's negative, I'm frowning. I have got the maximum problem. Therefore, it's concaved down. Concave down at x equals negative 2. In the B part of the question, they say determine the coordinates of the point of inflection. Now the point of inflection, point of inflection is where my second derivative equals 0. In other words, therefore that is where 6x minus 6 equals 0. The negative 6 goes to the other side. It's plus 6 divided by 6, so x equals positive 1. Just like we always had our gradient tables, we need to know the point of inflection if they have double signs. So what I'm going to do is I'm going to have a gradient table that looks like this. I'm going to have a gradient table looking like this. I'm going to have x and I'm going to have my second derivative of y. I need 3 values. 1. At 1 I know it is 0, I just calculated it. So I'm going to need to look for a value on the left of 1 and on a value on the right of 1. I'm just going to try to see what happens at negative 1, at 0. So if I put 0 into my equation, my second derivative over here, where's my second derivative? So if I put in 0 there, my answer is negative, right? It's negative. If I put the value to the right of that, so let's say positive 2, if I put 2 into this equation over here, 6 times 2 is 12. 12 minus 6 is positive. It's going to be positive. And I can say, therefore, x equals 1, or x at 1 is a point of inflection. And the point of inflection is when x is 1, put 1 in there. They ask for the coordinates. So when x is 1, what is y? Probably still have to show that. If x is 1, what is y? So going to the y at 1 equals 1 cubed minus 3 times 1 squared. That will give us 1. Take away 3 times 1 squared. That will give us, this is 1 cubed. 1 take away 3 is negative 2. So my point of inflection is at 1, negative 2. Because they ask us for the coordinates of the point of inflection.